Okay, shh. Hi, back here. All phones away? Good. Um, okay, so you guys are lucky, third hour, because in this shortened schedule, you get 52 minutes of Samulus. Yes, the genius of scheduling here at Lockport. Shortened. Yes. You had me third hour? No, wait, you had me sixth. No. No, sixth. 6 hour, you had it great because it was only a half. It was only half a period. Oh, well, yeah, that's me. That's the Samulus effect. All right. So this will feel like 4 periods. Okay. All right. So I gave you notes only because first, second, and sixth were short. So I gave you a skeleton because they hopefully made it work faster for them. And then by second hour, we still didn't quite get. We kind of got to the end. I got the last example done. You guys will be fine. So. All right, so we're going to continue in the spirit of what we did Friday and have fun with it. Yeah. Okay. The whole idea, and I'm going to stay right here with the words underlined sample and population. What population is, if we're talking about people, I don't know what the population of Earth right now is, but it's like 8 billion maybe. Let's just take a guess. 8 billion people on Earth. I don't know. That's the population. If I wanted to do a survey to try to see how these 8 billion people feel about a certain thing, I can't ask all 8 billion people. I'd have to get a sample of that 8 billion people. Let's say 1,000. Would that be a good sample, by the way, 1,000 people to emulate 8 billion people's feelings? Probably not. And that's the idea of what the sample, the size of it matters, and how you select those people matters. And the first one that we have for the day is demographically. Sometimes that's how we look at statistics because we feel people in certain demographics feel the same way about certain things. Whether you like that or not, or whether you agree with it or not, it is done. And that is what happens. And it's not perfect. So that's the idea of sample and population. You're going to hear that all the way through May. There's things called population standard deviation as opposed to sample standard deviation, and differences how things are looked at there. As I'm on my second year of teaching this, you get a better feel for doing this. Then what did I do this morning? You could turn me in, all right? Actually, I did it on my own time, but in our useless late schedule morning meeting things that hopefully are destroyed next year, I actually looked up our demographics from our 2017 report card because I wanted to update the numbers. So you have that as your first example. According to what they posted, at the point that they looked at Lockport, there was 3,712 students. To be honest with you, that number probably changes weekly. Students leaving the district, students coming into district. And I don't know if this can even happen anymore with the new laws of Illinois. It was very hard to get someone kicked out of school these days, but if someone gets suspended, things change. Yes? Yeah, I'll show you. Hey, Judge. I know. I write like chicken scratch on this. I got yelled at last hour. Okay, and then what I did is I looked up the demographics. And I'm just going to leave this up here. First hour, I had someone help me calculate all these numbers, and I don't think this is mathematically a big deal. And I'm going to turn off the lights for us in class so we can see this as I explain further. To the left, these were the numbers of students from each demographic of that 3,712. 227 identified as African American, and probably what you did is you filled out certain things that we calculate. When you first came into the school district, you probably had to fill in a box, all right? And then that's where that data is coming from, what you identified yourself racially, I guess would be the best way to say that. 11 American Indian, Asian or Pacific Islander, 59 Caucasian, 2688. You can read the numbers. So step one, if I want to get what was this called again? A quota sampling. The quota idea is we are percentage-wise going to match the population's percentage. Okay, so what's population mean for Lockport? The whole population is 3,712. we're just going to do a Lockport survey. Lockport students, full total population is 3712. From that, you're told to do a survey of only 751. 751 needs to be your sample. If we want that sample to represent the population, one way we could do that is try to proportionally represent all the demographics. And again, whether you agree with it or not, or if you want to say something about that, it's done in statistics a lot. You hear it a lot. So, what's the first thing that we did? African Americans, just to zoom in if you can't read my chicken scratch. There's 227 African Americans. That's out of the total 3712. That is 0.061%. I'm sorry, that's 6.1% of the population. So what should happen out of this 751? 6.1% of that 751 should be African American. All right, and then so on and so on and so forth. That's what all of these columns mean. I got the percent of the whole population that each demographic represents and multiplied that by 751 in order to see how many of the 751 should be from that demographic. So it's proportionally representative, a simple quota sampling. And then probably overdone at the right, but when I did this, I got a bunch of decimals and I got worried. Okay, how do I round the decimals? Mathematically might be right, but what if 3 of them round up and I end up with 752 when I only needed 751? So what I did, and what we did first hour, was leave the decimals, 45.92, that was the African American demographic, 2.25, 12.02, so on and so on and so forth. Then we added the integer parts of those decimals to see how far we were short, just to make sure we don't make a mistake on how many total we have. And when we added that, we had 749. And I know we're doing a lot of writing, so I think I have time to kind of add to this. These integers added together ended up being 749. And I'll write that down here. Again, I was just being overly cautious. Well, I need 751, so I need 2 more. So what we did, I actually said the wrong thing. I said the Adams method. But it actually is, I already forgot. The Lowndes was the relative fractional part. Hamilton method. Anyone remember the Hamilton method for the presidential thing? Picking people. We picked the fractional part that's left over and then gave the highest fractional part the next 2 numbers, which were the only 2 that rounded up. I may be mathematically incorrect, but I really feel like there is a possibility that 3 of these could have rounded up. And then you would have ended up with 752 people. And that'd be wrong. You only have to have 751. So I rounded the highest fractional one up first, then the next one, and so on, until you hit the number itself. Okay, so of those 751 people, these are the demographics that should be represented for your survey. All right, and then I'll give you some time to finish up. What? Okay, so again, probably overdid it on getting those integer parts. Hey, those integers only add up to 749. I need 2 more. So then I went ahead and rounded those 2 mathematically up, but the ones that had the highest decimal. Okay, not that we're going back to that thing I mentioned about the presidents. I just thought it was a good idea, good memory. Okay, now the next one. Can everyone say stratified sampling? Well, like 3 people. Okay, now the last one was fixed. I had to have 751 people. That's fixed. This one's fixed. And it's sort of like the last one, but before we... Well, it is, actually. But let's say this one, the subdivisions are not demographics. There's something different. Okay? And still, it's still a little bit similar to the last one. It really is. Okay, so stratified sampling, population subdivided into 2 or more. What's that word? Can anyone read that word? I was getting yelled at. Non-overlapping. Thanks. What's that word? That's you. Subsets. I know. It looks like you know. See, I don't want to touch this thing because look at what happens anytime I get close to the screen. All heck breaks loose. Each subset or stratum, can everyone say stratum? Don't. Should be more homogeneous or homogeneous. Homo means same. I love words. And then genus means race or kind. But in this case, we're not talking about demographics that way. So each subset should be more homogeneous or homogeneous than the entire population. And then this is how it is a little bit different. We're going to go to our chart. That's when they say SRS. We got to use some random numbers to randomly pick some people. So it's a combo of the last thing that we did, a quota, but then we're going to use an SRS. And we could have used an SRS in the last one. Okay, I have X amount of African Americans I should choose from. Now, I'm going to number them, and then I'm going to randomly pick, from each subgroup. That's what would happen in this one. Last one, we just get a bunch. The randomness of selecting people sometimes is a good way to represent a population, meaning pure randomness of picking people actually gives you a better shot of emulating how the population feels as opposed to specifically picking people like your friends. I was going to pick all my friends for this. Well, they're your friends because they usually have the same feelings as you about stuff. All right, so therefore that would not be representative of the population. Does that make sense? That's why we had that random generator of numbers here for this. To get a stratified sample, let's just do it. Hold on. Nice. I did get rid of it. Okay, but I did want to leave some stuff here, and I'll explain some things that are written. I did this for speed in the other hours. First hour, I took too long to write everything down, and then we really ran out of time. Okay, so now look at this, and if you weren't here Friday, and I have my chart in my hand, by the way, you should get your 9-4 chart so you can play along. Call it the 9-4 chart because it's called figure 9.4 in your book. An obstetrician has 156 patients they're expecting. 75 are expecting their first, 54 are expecting their second child, 27 are expecting their third. These are different demographics because these are different people. Someone expecting their first child scared. Then when they have that child, they treat that child like a piece of glass. Oh my gosh. All right? And then by the time they have the third child, they let them play with a bag of glass because they couldn't care less. Oh, they'll be fine. Right? Anyone a third child? And here I am. Yeah. I got cuts all over me from the bag of glass that I got for Christmas. Isn't that a great story? All right. All right. So a doctor wants to test a new painkiller on 25 women. So we got to get a 25 women. That's why it's fixed. Okay. So let's look at how we separated the stratas. And you could say, well, can a strata be like a demographic? I guess so. That's where this is similar. But what we do next is a little bit different. So the stratas are how many children these are, what child this is for the woman. This is the group of, this is their first child. Now, there are 75 people. I'll tell you why I have this 1 through 75 later. Then how many people are on their second child, 1 through 54? And then third child, there's 27. So I have 1 through 27 there. I'll tell you that in a minute. Well, the first thing is, just like the last situation, this is where this is almost exactly the same. It is, actually. What percent of the women are having their first child? Very simple. 75 out of 156. So for the 25 women that we're choosing, 12 of them should be from that group. See? I took 75 divided by 156, which is the percent that are having their first child, and multiplied that percent by 25. And then again, I did the decimal thing. I'm going to wait to round, although 12.02 probably will end up being 12. 54 out of 156 is the percent having their second child. So that's how many out of the 25 there should be. 8.65. I'm going to hold off on that. 27 over 156, 25, 4.33. I add up these integers. 12 plus 8 plus 4 is 24. I am one short. So, yes, the one that rounds mathematically is the one that will round. So 9 should be from that group. Okay, now this is what I do. Let's go back up to this. And those that were absent, you better listen. And you should have watched the video. Tired of it. Ah! Then they come in Monday complaining they don't know what they're doing. They're their own worst enemy, right? Frustrating. Yelling at me like it's my fault. You want me to come over all weekend? Here, watch the video. I'll press play for you. Better have dinner for me at least. Oh, okay. All right, so here's what we're going to do. Use the chart 9.4. Start at row 103. Where did that come from? Where did that come from? It starts with an R. A, huh? Random. Good. You got it. Right on the first letter, R. It's random. And it's listed, it's listed in the book where you're supposed to start. So start at 103. Can you see that? I don't know. It's dark in here. Okay, 103. Use the third and fourth digits of the third column. If you're with me, what is that number? 23. Fumble. Yeah, good, that's your phone. I hope it broke because you're not supposed to have it in class. All right, now, here's what we got to do. Why do I have 1 through 75 here? All right, the amount of women that are having their first child is 75. I'm going to randomly number them 1 through 75. I could do it alphabetically. The one with the last name A, 1. The one with the last name Z, 75. Now I go to that list, and what was that first number that we saw in row 103, third and fourth digits of the third column? Is that a woman, yes or no? Woman number 23 is getting picked for this situation. Then what's the next number? I can't see. I got to go by the light over here. So what's after 23 if you go down the column? 20. Is that a woman? What's the next one? 2. Is that a woman? 0. Is that a woman? No, we start with woman number what? 65. Where is he getting these numbers from? 23. What's 23? Get out of here. Don't you dare start that. What's 23? A what? Repeat. 93, a woman? No. 42, a woman? Yes. Okay, so basically we're looking at figure 9.4, going down to third column using the third and fourth digits, and that's where these numbers are coming from. I don't think I have to do the rest of this. We ended up with 31 here. That's a repeat. 82, 36. Now, hold your spot on that list. So these are the 12 women from the first child list. Now I'm going to keep going down that column. What's the next number? What's the next number? You don't have your list. 54. Okay, now what I do is now I move on to the second child list. I number those that are having their second child 1 through 54, and I keep going. And lo and behold, the first number I see after 36 is what? 54, and that's a woman. So we're going to select her. 29. 61, yes, no? 53, yes, no? 96, 45. Those following along in their list, you know exactly what's going on. 16. Random. Randomization of picking people sometimes is a good way to 95, 51. Pick a sample that would more than likely emulate a population. 55? No. 2. Stop at 2. Now we go to the third child list. Okay? Right, 2. Did I make a mistake? No. 7 was 1. 55 is not a person, and then 2 is. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Someone's yelling at me. Hold on. Next. All right, and then last but not least, number the last people 1 through 27, and then continue. 2, no. 14. Is that a person? I think these actually work out nicely fast. 14, 25. Is that a person? So you not renumber. Now you number the people that are having their third child. 35. I did 2 65s, then a 35, then a 1, right? Okay, so it ended at 1. There's those 4 people. And if you have any repeated numbers, they're not repeated people. They're from different stratas. These are different people. Okay, so randomness. I know this is weird, but it's just away. Let's just call it that. Softball, right? I could tell your softball coach that you refuse the phone, then you'll be suspended. Come on, let me have it. Let me have 5, 4, 3, 2. Thank you. Oh, softball, the power. There's no way you literally stab me in the back. Literally stab me in the back while I'm doing notes. You're on your phone. Okay, well the light's on. It's very important to be in the notes right now. Okay, here we go. Now do the next part. It's good. Hope you texted your friends. All right. Cluster sampling. Okay, this is different, and I know it's getting weird. This is the end of like sampling, and then we're gonna move on to doing other stuff. So, just giving you some ideas of how things can be done. And I made a note last hour. I didn't say this first hour too much because we did run out of time for this one. What's a cluster sampling? It's not a demographic, so to speak, or I don't want to call having a baby a condition, but like like these, are what attributes they have. This is just a good idea of what cluster sampling is where you live. So I want to do a survey. And my clusters are Lockport, New Lenox, Minooka, that's where I live, and Joliet. Joliet's huge. I'm going to randomly pick one of those clusters. Lockport. That means I'm going to ask everyone in Lockport, and that's my cluster. There's not a percentage of people in Lockport that I'm going to pick. That's what the difference is. That's what a cluster means. So non-overlapping subsets, you don't live in Lockport and Joliet. May vary in size. There's one or more elements in a cluster. That's not really a big deal. And I hate this word frame. I'm not sure. This is what the book calls a frame. So don't worry about this too much. The frame is the complete list of clusters. That would be Lockport is one of the clusters. Joliet, Minooka, New Lenox. All 4 of those listed together is called the frame. I hope that's not on your test, like as a vocab word. Words that are important in vocab, I don't feel that one is a good one. Then, of course, sample is the group of clusters selected from the frame, or one of the clusters. The sample was Lockport. All right, we're going to use Lockport as the sample. We're going to interview them, and then from that, well, hey, we just got another phone checker. You guys got problems. Oh, what just happened? My phone buzzed. Oh, who was it? Oh, it was Sally. She just sent me a selfie. Look at her in English. So important, these kids these days. So ridiculously important. I do have to take it.
Emails from AP test. That's got to be the best one I've heard.
Okay, here we go. All right, so non-overlapping subset. Complete subset. A group of clusters selected in the sample. Well, that was that example. What's the sample? Lockport. I'm going to use Lockport as the sample to emulate how Joliet, Minooka, New Lenox feels about a certain thing as well. Okay, so that's what the idea is. Not fixed, because Lockport, Joliet, Minooka, New Lenox have different populations. If New Lenox was picked, then it would be a different number of people that I would be calling on. Correct? All right, and then this one, we're going to use an SRS for the clusters, not individuals. Okay? So again, big differences of this is we don't take Lockport and then from that take a percentage of the people. The whole cluster's coming. Okay? And that's what we're going to do. All right, so, I got rid of this. Darn it. Okay, so I got to write this. That's fine. Here we go. Let me see if I can go off of, let me look at, I hate to turn my back on people, get stabbed right away, but I'll come over here from now on. Oh, yeah. Uh-huh. Okay, sure thing. Can't wait. Okay, so here we go. Here are the clusters. We have Lockport. This is a stupid little study. You can read it. So a dean says, okay, you know what? I'm going to look at these 4 classes. This is the teacher that used to teach this class. Okay, and it's 4th hour, let's pretend. It's 4th hour, randomly. Okay, this teacher has 27 students. I'm just going to put ST. And then this one, who's still here. No comments about teachers. I hate him. I like him. He's better than you, Mr. S. I don't care. Okay, Dorencott. Oh, I love her. She's so nice. We'll just call her Dorcott. Shh. All right. 25 students. So these are the clusters. All of these listings of teachers is the frame. Whatever. Is there a Geiger here? Maybe they retired. Maybe last year's students knew a Geiger. I don't care. I should make it current teachers, but it doesn't matter. I don't know who this is. I don't know who anyone is. I don't hang out with anyone, so. Voight seems nice, but eh. Garrett. You know where Garrett is? Quit teaching. You want to know why? Common Core. True story. You can ask her. And all the changes that. No, shh. Keep that secret. Okay, so there's the frame. No. Now what we're going to do is label the clusters. And how we're going to do that is numbers, because then what I'm going to do is, we're going to say a rule for how we're going to pick these. And again, that is random. So we're going to call, look at that, Garrett with a 6 right next to her. See how my G's are almost identical? 6, Garrett. All right, let's move on. All right. Now, how many clusters am I going to need? Number. There's another phone on the ground? Ridiculous. So again, I try to do the notes. This is when they good. I hope it breaks. I should step on it. Oh, all right. Number of clusters. How many clusters do I need? Not 6. How many clusters to satisfy the situation? Last hour got it. Read the question. Nope. There's only 6 clusters, so we're going to be 8. What's the biggest cluster? 32. How many students am I supposed to have? I don't know why that is. So is 1 cluster enough? Is any 2 going to be enough for sure? Yeah. Okay, so number of clusters will be 2, because then that will at least cover this 48 that I have to have, according to the rules of the survey, whatever this person is deciding. Number 3, what is the SRS? What are we going to do in order to select these randomly? And I could just, without looking at my number list, go, but I'll do the one that we did last hour. Row 128. Why only a row 128? Because I only need a single digit, right? So if I only need a single digit one time, is just to move across the row until you get what you want. Okay, well, look at that row 128. What's the first number in that? 128 is a 4. Is that a winner or not? 4 is a winner. In row 128, 4 is the first number. So this is the one class I'll select. Then 0, then 2. Voight is the other class. There's my 2 that I'm going to go to those and then survey those students. So notice the difference. I take them all together, no matter what their demographic is. They are in a cluster, which happens to be just in a certain class. All right, and that would be it. So I would do a total of 61 students, which covers more than I need. This is why it's not fixed, because you're taking that whole group. So understand those differences, and then don't worry about these last 2 things. These are just kind of thrown together. What would be a convenience sample? Well, I can't do any of the last things that I did because I don't know any information. So convenience means I'm just going to sample who I see. That's my sample. So convenience sampling just consists of only elements available to you. You may not have any other choice. So you may not be able to do anything fancy. And then what does a census do? This deals with the whole population. Whenever you're talking about a census, you're trying to get the whole population, and you're trying to measure a variable of that whole population. So that's what the word What's a measure a variable? Measure an idea. Measure what you care about. Okay, so just write those down at the end. Those are just random tacked on to finish 9.1 and 9.2. And then what I thought I'd do is this, what you have on the other page, just to remind you Friday and Monday. Okay? And then what I did on the bottom was I put the examples of them just to help you out. What was a simple random sample? Well, that was our, geez Louise, that was our simple little thing where I had 20 people. I numbered them 1 through 20, and then I went to table 9.4 and went across a row and just picked them, right? That's kind of what I did with the cluster sampling right there at the end, but I had to get the clusters first. So that's what that represented. That's my work from Friday, just so you could remember these and have them on a page to kind of close this section. What's an independent sampling? That's that percentage sampling. Okay, so that was a little bit different. This is not fixed. Notice that we have that in that column. That was this one, where a 40% sampling meant 0, 1, 2, and 3 were in. 4 through 9 were out. And then I went along a row or a column, and then I picked those numbers, and any number that ended up getting a 3, 2, or 1, or a 0 ended up being in the sample, those not in the sample. And then the last one was, I should have done this, but a 1 and 4, I'll do it now. 1 and 4 means I should number 1 through 4 the first 4, then 1 through 4 the second 4, then 1 through 4 the third 4. And I verbalized this but did not do it. And then you go to your table through whatever rule they say, and you find which number comes up. And then 2 came up. That means everyone with the 2 is in the sample. Okay, so that was from Friday, and I thought that'd be a good idea to share that with you here. That was the 1 and K one, if you want to go ahead and get that down there. Then the last 3 that we just covered. And I just wanted to make sure you understand the difference between these last 2. There are similarities, okay, but the cluster sample is you take the whole group together. All right, so you put these in clusters, and then you pick a cluster, and they all go. The previous ones, we put them in stratas, and then from that, we get a percentage of each strata, and then randomly select those through the 9.4 thing. And then the first one is just kind of in general, a quota sample. I got to make sure that my sample represents the population's percentages, in this case of a demographic. But then we didn't do anything after that. So I thought that'd be a good little thing to share at the end that actually has some value to close up this